Hello, you are welcome to my channel. The question I have here says, at sea level, a barometer reads 760 millimeter mercury. In a plane, a barometer reads 725 millimeter mercury. Find the height of the plane above the ground. And then we are given density of mercury as 136,000 kilogram per meter cube, and density of air as 1.23 kilogram per meter cube. So we're asked to find the solution of this problem. So now, let me start by writing out the given parameters, the given quantities in the question. We are given the pressure at sea level, so I'll call that PC. The pressure at sea level as 760 millimeter mercury. But in this problem, we are going to be using pressure in meter mercury, not millimeter mercury. So to convert millimeter mercury to meter mercury, we simply divide by 1000. That means it is similar to when you want to convert millimeter to meter. So to convert millimeter to meter, you divide by 1000. So in order to convert millimeter mercury to meter mercury, we are simply going to divide that 760 by 1000. And that will give us 0.76 meter mercury. Then similarly, we are also given the barometer reading, that is the pressure now. Don't forget, these values are pressure values. We are given the pressure value at a plane, that is an airplane is above the ground, far up above the ground. Then we are told that the reading there is 725 millimeter mercury. So we are going to take that as the pressure at the height. So I'll call that pressure at height now, because the airplane is up above the ground. So that will be, as usual, 725 divided by 1000, because we are converting it to meter mercury, divided by 1000. And that will give us 0.725 meter mercury. Meter mercury. Now, what else are we given in the question? We are given the density of mercury. I'll take that as rho. Please, this is not P but rho. The symbol for density is a Greek letter. So rho, density of mercury, I'll call it M. Rho M as 136,000 kilogram per meter cube. So that's the density of the mercury. Don't forget, mercury is used in barometer. And then we have the density of the air. So I'll call that rho A. Rho A is equal to 1.23 kilogram per meter cube. So now that we have highlighted everything that we need in the question, don't forget we are looking for the height above the ground, which is H. So question mark, that's the height of the airplane above the ground. Now the formula to apply in problems like this is to simply use the density of air, that is rho A. Let me say, therefore, the density of air, that is rho A, multiplied by the height of the plane above the ground, and that will be equal to the density now of mercury. The density of mercury, which is rho M, multiplied by the difference between the pressures at sea level and at that height. So the pressure at sea minus the pressure at that height above the ground. So this is the formula that we are going to be applying. So the density of air multiplied by the height of the plane above the ground is equal to the density of mercury in the barometer multiplied by the pressure at the sea level minus the pressure at that height. So please don't forget this important formula, which can be applied in problems like this. Now we are going to substitute values so that we can get our answer. So the density of air we can see is 1.23. So I'm going to say 1.23 multiplied by the height that we are looking for, and is equal to the density of mercury, and that is 136,000 multiplied by the pressure at sea level, which is 0.76, minus the pressure at that height, which is 0.725. 0.725. And that will be equal to 136,000 multiplied by 0.76 minus 0.725 is going to give us 0.035. 0.035. So don't forget we have 1.23h here. 1.23 multiplied by h is 1.23. So we are looking for the height now, which is h. So I'm going to divide both sides by 1.23. So also divide this side here by 1.23. So that I'm going to get the value of h. And now this 1.23 will cancel 1.23, and I'm left with the height h. So I'm left with that h value now. And then I'm going to divide this other side now. So 136,000 multiplied by 0.035 and then divided by 1.23 will give me the height of the plane above the ground as 3,870 meters. This is the height of the plane above the ground. This is the final answer. Hope you enjoyed this video, and please try and go through it again so that you can understand this problem like this, which is a very tricky problem. Thank you for watching, and I'll see you in my next video.